Hello world, we are live. Welcome to the Getting Rusty, a workshop on the Rust programming language. With ourselves, we have Forrest Anderson, who is a game developer who codes in Rust, and he is also a part of the development team of Valorant, and he has a lot of experience giving talks about Rust. Here we have him. We welcome you, Forrest. Thank you very much for coming to our community and giving this talk. Over to you.
Perham, thank you so much. As anybody who knows me knows, I love talking about Rust, and so I'm super excited to be giving this presentation over the next hour. And so we're going to dive right into it. I've got a lot of content to cover. And so first off, with a small introduction here. So as Perham mentioned, my name is Forrest. I'm a student in Ottawa at Carleton University. And like Param, I'm also a GitHub campus expert. And so I think you probably noticed that we both have our red hoodies on. And so we do like having, oh, and I got my box right over here. So very cool. I'm also a big advocate for open source development. I've done a lot of work in the game dev field, and I've done a lot of work as a Rustation in this field as well. And so there's definitely a lot of super interesting stuff that we're going to talk about today. And we're going to be finishing off this talk diving into a little bit about the community. And so I'm super excited to get started. Oh, yes. So the workshop, a little bit about the overview. We're going to start with this presentation and intro to the language, but then we're going to get right into a sort of demo workshop kind of thing. And so in the chat of YouTube, there's a link to a Notion document. And in there, we'll follow that for some of the more interactive part. I'm also going to demo a little bit about what using Rust on my own computer looks like. So what the development environment is like. And then we're also going to take a look at some resources so that you can potentially get started using Rust yourselves after this workshop. And so I also do want to start with a word of warning that I talk very quickly. And so I already see that there's some people in the chat. If I'm speaking too fast, if I'm difficult to understand, just tell me. It's very easy to slow down once I see people mentioning that, but I naturally speed up. And so do mention that. And also, if there's something that you don't understand, please ask, because I'd love to elaborate on parts that are difficult to understand. So maybe if someone's watching the YouTube video later, they'll be able to understand stuff more easily. So let's get into Rust. And a little bit more of a background for myself relative to Rust. As Param mentioned, I am part of the development team working on a game called Valorant. This is a game that I've been a part of for about almost 3 years so far, since 2019. So I guess 3 years, exactly 3 years. That's pretty crazy. But it's a game that's fully built in Rust. We're doing a lot of really breaking edge stuff with what Rust is capable of. Really pushing it to its limits for our multiplayer server and how it renders the world and a lot of this stuff. And so super exciting to be working on this. And then as part of this, I also have gotten introduced to a lot more of the Rust community. So I'm part of the Rust game dev working group as well. And so this is a working group that focuses on outreach for game development, running meetups, doing a monthly newsletter. And so we can see I was the editor for the November newsletter. There's the meetup I run. And we get to see a lot of the games that are being made in Rust. And so this is the side of Rust that I do most of my work in. But I'm also a team lead of the Rust cross-team collaboration fun time, which is an interesting meetup that happens once a month where core Rust teams can give presentations that matter to one another about more meta topics. And so that's a super cool thing to be a part of as well. So let's take a look at what the Rust language actually is. And so a lot of people have probably heard of it. There's definitely a lot of hype around it. It's a systems language. It's compiled, so sort of similar to C, C++. It's very good at doing concurrent work, and so doing stuff either on different threads or in async. It has a very strong type system. And one thing that's quite interesting is that when we think of going to use C and C++, we think that if we want to solve a simple problem, it's easier to do it in Python because we can very easily just get what we want written down. Whereas in C and C++, you have to be a lot more verbose. But Rust does a very cool thing where it sits in the middle, where it feels like you're writing almost Python a lot of the time. It's very ergonomic and it gives you a lot of tools to accomplish a lot very easily. but then it also allows you to go as low level as C and C++ very easily. So I do want to start off by answering the question, though. Why are we trying to reinvent this wheel? Clearly, like C++ already solves a lot of these problems. And it is already very popular, is very low level. But I'm going to talk a little bit about what Rust brings to the table. And Rust has one very, very big core feature. And this is the idea of memory safety. It has a lot of other really cool things. Like I love the match statements. You can use them with enums very nicely as like exhaustive matches. You can do a lot of really great stuff with error handling. And there's a lot that the language gives you that's really awesome. But memory safety is one of the big core features, just because no other language does it in the same way. And so memory safety means that we can work with computer memory without the fear of making mistakes. But then if you think about it, like, what don't we have this with other languages like Python and Ruby and C# and a lot of other languages? But the problem with these is that they're all garbage collected. And so you do get a lot of memory safety benefits from these other languages, but every once in a while, some process has to be running to go and clean up everything that you're not using anymore. I want to take a quick look here at, I don't have my time up, so I'll try to go as fast as I can. I'm taking a lot of this from an old talk that I gave, but it's still quite relevant to sort of like what memory safety in Rust does. So we take a look at C++ here. And what we find is that like we can allocate some space, and we're allocating it on the heap. And oh, hello, Mukal. Hi, very cool. We got some people here in chat. So we're going to do something with this memory. So on line 6, we set the array at 0 to 1. And then when we're done using this memory on the heap, we have to free it. And so with C++, we are able to accomplish like a lot of this low-level stuff. We don't have a garbage collector. But then the problem is that we're coming back to the problems that we were trying to get rid of. So seg faults are prevalent in C and C++. And double freeze, you can make mistakes around those a lot of issues with null pointers. And so with Rust, and let's take a little look at an example here. This is some Rust code. And so in this one, we're going to allocate some data to the heap, just as we were doing in C++. And then we're going to use it for something. But we don't have to free it afterwards. And so this is one of the guarantees that Rust gives us, is that it can handle a lot of memory management for us because of the rules given to us by the compiler. And so just explaining a few of these rules, we're not going to go super in depth. We're going to do a lot more through example. But with the guarantee of memory safety in Rust, it comes from a few different things. And one of the big ideas is ownership. And so there's a few different rules of ownership. And so this is just like a very high level type of thing. And these are things that are all done at compile time. So Rust will make sure that each value in Rust has a variable called its owner. There can only be one owner at a time. And then once an owner goes out of scope, the value will be dropped. And so that's what we were seeing before when we were allocating space. Once that the value that was the owner of that memory went out of scope, then it was automatically dropped. And then we have this idea of moving. And so let's say you have some value that's owned, that has this one owner, and you want to send that value into a function. Then that's known as moving. And so now that value is owned by something else. And the original owner can no longer use it. And so we can do this one through assignment. We can do this through passing into functions. And I do want to mention that you are allowed to, hey, that's how smart pointers work in C++. All right, but let's take a look at this. And so we have on line 9 and line 12, we're allowed to do drops in Rust, which is the same as freeze. And the thing, though, is that this is a double free. And so we're trying to free memory twice. And this would result in a seg fault. This would result in like a whole bunch of yucky stuff. And so in Rust, though, because we have this rule of ownership and memory management, this will give us a compile error. And it will tell us that v has been moved into this drop function. And so we can no longer use v here. It's no longer valid. And so that prevents us from double freeze. And this idea of ownership spreads across like the entire code base. And so in Rust, we get two very popular sayings. So first of all, fighting the compiler. And this is the idea that when you're going through and writing your code, your compiler, like the Rust compiler, will tell you that you're moving stuff, that you're doing things that you shouldn't be, and you have to go fix your code. But then the second one the second saying, if it compiles, it probably works. And so this is where we get the benefits of the compiler, where as soon as it compiles, all of these guarantees about memory safety are in place. All of like Rust has gone through and added all of the places where it needs to free memory so that you don't have to. And when your program is running, it's running as fast as C++ because there's no garbage collector. And at run or at compile time, you have all of your guarantees. And so we often call this the contract with the compiler. And one of the really great things about this this sort of contract is that it gives us a lot more trust in the programs while we run, but it also gives us a lot more trust in the teams that we work with. Because if we can compile our code on our computer, and then we merge it with some code that other people are working with, we can be a lot more sure, a lot more confident that everything is going to run properly. All right, so we'll take a little bit of a look at Rust syntax here, and this will be quite a quick overview. But what I want people to get out of this is that just kind of what things look like, and then once we go into the workshop section, we'll be able to explore a lot more how things are actually like being implemented and what it looks like when it's running and compiling. So a basic Rust program, to get something started, we start with a main function. And so inside of this one, if you take a look at it, like, okay, we're assigning 5 to A, and we're doing something called a print line, and we're printing A. And so, I mean, it would have been smart for me to show off hello world, but I kind of wanted to show like a little bit of variable assignment. And so we can see here there's some interesting stuff. First of all, on line 2, we have this idea of like let A equal. And so similar, I suppose, to like maybe TypeScript or JavaScript, you have like the let keyword as well. But then on line 4, we have what's called a macro. And so in this case, for print line, this allows us to print to the console. But the exclamation mark means that there's more happening behind the scenes that than we see. But it gives us a very nice and clean way of doing a lot of more advanced functionality. As for variables in Rust, we have 3 different sort of ways of handling stuff here. So first of all, line 1, if we break this down, let A equal 5, but then we also have the I32 there. So that's a little bit interesting. So the way that you read this is let A, which is an I32 type, equal 5. And we'll get into the variable types in the workshop section, so don't worry too much about it. But what this is this an integer, or rather it's a signed 32-bit integer. On line 2, we have something else. We have mute in there. And so let mute b equal true. But you'll notice a few things here. First of all, we didn't say that b is a Boolean type. And second of all, what's mute doing there? And so in Rust, all variables by default are immutable, meaning that once you set them, you cannot change them. You specifically have to say mute so that a value can be changed in the future. And so line 3, we're putting this all together. We're saying let mute C, which is an I64 type, equal 9 billion. And what I wanted to show off here is that if we put I32 in here, then it wouldn't be able to hold it. 9 billion, like as far as I know, is bigger than what a signed integer can hold, or a signed 32-bit integer can hold. Also, we get like this nice little syntax where you can put underscores in numbers so that it's a little bit easier to figure out that this is 9 billion. All right, so moving on here, we have some control flow stuff. And so if statements, some notable things here, similar to other languages, but you don't have to encase your like Boolean statement in parentheses. And so in other languages, you might have if open parenthesis a is greater than 5, close parenthesis. But in Rust, you don't do that. And it will even complain at you if you do that. So I like this. It's a lot cleaner. It's a lot easier to read. Of course, you can add parentheses if you need to do more complex logic, but for the most part, they're just extra syntactic sugar. Control flow for like for loops, we have pretty standard, but a little bit interesting, where we have this idea of a range. So we can say 0.10, and this range is inclusive, exclusive. And so what this would print out is actually 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And so we use like the n in something syntax. We can also do like n in some iterator. And so maybe if we were iterating through a vector of numbers or like an array, then we would use the in syntax as well. Functions. Now this is where it gets a little bit interesting, because these are a little bit longer, a little bit more to take a look at. But let's break down line 1. So right here it says, and how you would read it, function with the name is divisible, takes in a, which is an integer 32, and b, which is an integer 32, and it returns a Boolean. And so this is quite different from other languages where you might have, I guess, like Java's like public static void, which, so void is the return type. Public is if something's public. And so in Rust, I could also do like, let me just edit this. And so I could do like pub if this was in a module, for example, then I could use the pub keyword to make it public. And so it will return a bool. So if we take a look here on line 2, we have if a modulus b equals 0, we're going to return true, else we're going to return false. So yeah, someone mentioned in the comments, very Python-like, and this is absolutely true. There's a lot of stuff here that, actually, wait, I guess, yeah, if you're returning something from a function and you're using like typed Python, then it's similar to that. And also of recent, Python has added match statements, pattern matching, which is very, very cool. Rust pattern matching is super awesome. Okay, but so this is like pretty standard in languages, but let's do it a little bit more rusty. So what we can see in the second one is we don't have the return true, return false. And instead we just say true and false. And what happens here is that the last line of a function that executes, we can, instead of having to say return and semicolon, we can just put in the value that we want to return. And so this still has like the if statement, but on line 2, a modulus b equals 0. That's still a Boolean statement. And so instead of getting it to like say true and false, why not just have that statement itself? And so in a lot of Rust functions, we get used to this idea that the last line is going to be what is returned, which is very nice because then you can just look at the bottom, you know it's going to be there. And then if it's somewhere else in the function, we still do use a similar syntax of return true, return false. All right, so now we're at the end of like the intro presentation. We're going to hop into like the workshop part. So let's take a look here. So this is in the chat. I think it's on YouTube. If you scroll up a little bit, you can go here and you should see this exact same page. Do let me know if yeah, okay, like Python and curly braces like syntax is something that someone mentioned in chat. So yeah, we do like the curly braces. We do like scopes. Very nice and clear in Rust. Yeah, so the document link is there. So you should be able to go and get on this page. And the goal of this document is that you can take a deeper look at it afterwards if you like. There might be some parts that are unclear, so feel free to ask about them. But then there's also a lot of resources at the bottom that you can use to get started with Rust. And also we have the presentation here. Very cool. So Notion documents are pretty awesome. You can embed websites in them. Hopefully this is like a way that you can come back and enjoy the workshop at a later time as well. So we're going to start with some practice down here. And so actually, let me see how much time do I have. I'm hoping this can be like a 40-minute workshop section. So that's like 15 minutes for the intro. All right. So we have the Rust Playground in here, and the Rust Playground is pretty awesome. It's a website that you can go to and you can run code. And so, for example, I can open like this permalink and get the full website. Ooh, let me, I'm sorry for, it's the default background is white. It looks worse when it's dark. For all of you, if people are watching in India, I know it's pretty late at night, so I apologize for all the white backgrounds. And if you're in Canada like me, maybe it's waking you up a little bit. But anyways, with a playground, it's pretty awesome because we can run code in here, have it compile, and it's compiling on some server, and it will return the result to us. And so we'll be using this a few times throughout this workshop to try out some code, to play around with it. And if you write some awesome code and you want to hold on to it, don't leave the page because it doesn't automatically save. Like if I add some stuff in here and then I refresh this page, it's going to go back to the default version. Now you can keep it though. If you hit share, like if you do something and you hit share, it will actually generate a gist on GitHub and then reference that. So I can open this in the playground and it will store. Oops, it's not that one. It'll store what I have. And so be sure to use the share button. It's a pretty great way to store what you're working on. So as I said before, we have the main function to get started. We just have it doing a simple print line. And this is a pretty nice and compact like view into what Rust code looks like. It's nice and small. A little bit later in the workshop, I'll show you what Rust looks like on my local system, because it is, so this Rust Playground makes it feel like an interpreter. Like if I was doing like Python with I don't know what idle, I guess, but I'll show you what this project would look like in VS Code as well. So going over to syntax, I've included some links to pages on Rust by example. And so, for example, right here, I can see some information about primitives. We have like the different integers. We have unsigned integers, floating point. And so these are like the scalar types. And these are pretty nice and verbose about what they do. We can look at the integer sizes in this little chart down here. So for example, like an I8 can go between -128 and 127, whereas a U8, which is unsigned, so it doesn't have positive or negative, it can go between 0 and 255. And so we could kind of like use this chart to see what's going on. But let's get into a little bit of code right here. Okay, so actually it's coming through pretty okay. I think my monitor's contrast is not so great. Maybe, let me see if I can change theme to, what's a good one? Monakai, I think is pretty all right. Okay. I think that makes it look better on stream. Not sure. We got a decent amount of comments in here. So let's take a look at some of this code. So if we run it right off the bat, I wrote this code a while ago, so I'm not entirely sure what happens. Okay, well, it prints out some good debug information. So let's do a bit of code reading. So on line 2, we have a equals 1. So we're assigning 1 to a. And then we have b equals 2. And as I was mentioning in the workshop talk, we don't always have to specify what types stuff is. And so, for example, a, we're not saying that it's an I32. However, on line 6, when we say a plus b, and we need to debug that, then it's going to say, okay, well, if b is an I32, then that means that a must also be an I32. And if I were to try to do something later, like a plus equals something that's much larger than an I32, so 9 billion, then the compiler should yell at me and say, well, you said that a is an I32. Oh, well, okay, one sec. A is immutable. And so, as I mentioned, since we didn't add mutable in, a is not allowed to change. Now we've added it in, and it will say literal is out of range for I32. And so, because even though I didn't specify anything, it's going to assume that the type is I32 because b is I32. Actually, let me make this a bit bigger. I think I'm able to do that. Yeah, that's better. Oh, yeah. Now people on phones can read. Very cool. Okay, so, yeah, okay, so this is like an interesting one to see what's going to happen. So we're going to say C, which is an I64 equals 1. And we're going to try doing C plus B. And let's see what happens here. Because we know that B is an I32. We said B is an I32. But then these types should conflict with each other. And we should get a compiler error saying that not allowed. Yes, exactly. So expected B to be an I64 because C came first. But we found an I32. So let's try, what we can actually do is cast B to be as I64. Not 65, that's pretty wild. All right, so C plus B as I64. And then in this case, we're all good. When it prints it out, C plus B is 3. That's good. I'll leave the rest of the stuff here. You can do this like a little practice, play around with stuff a little bit and see how that goes. But we'll go on and take a look. We'll go a little bit faster just because I want to make sure we make it through everything. But with loops and control flow, again, we have like the great Rust by example. We can read stuff through here. This covers a few different pages about loops and how they work and stuff like that. Great read. But we'll talk about some of the syntax ourselves. And so starting with this one, again, reading through some code. On line 3 here, we have a for loop. And as I mentioned, this range means 0 up until 9. And so so I think what we should expect here is that it prints everything out from 0 to 9. So once it comes out, okay, perfect. We got everything 0 to 9, and then we got the second part, but that's from the second part of the function down here. So this is a for loop. When we're doing like a while true, so you want a loop that keeps on looping until some case inside breaks out of it, then we just use the loop keyword instead of while true, which I can put in here, and we'll see what happens. Outside, I'm making a variable a, setting it to 0, so this will just be our counter. We have at the beginning, a increases by 1. If a modulus 10 equals 0, then it's going to break out. So once a gets to 10, it will break out of the function, and then we exit the loop, and we'll see what it gets to. So the compiler told us denote infinite loops with loop instead of while true. And this is just a warning. I'm allowed to do it, but it's like you can do it cleaner. And we exited the loop at number 10, which is what we expect. Awesome. So a little bit of a practice thing for later, if you like, you can go through and write a for loop that prints all numbers between 1 and 50 that are divisible by 7. So kind of just a little practice, seeing how that goes. Now, in this part of the workshop, I talked about functions a little bit, but I do want to mention, actually, the formatting stuff, I'll talk about more when I can show you on my computer. But the main idea is that Rust has a lot of first-class tooling that's built into a program called Cargo. And so when you want to go and compile C and C++, you might think like, okay, well, if I want to include a library, I'm going to have to link it. I'm going to have to add that to my makefile or whatever. But in Rust, everything by default just works with Cargo. And so when I want to run my Rust program, I do Cargo run. When I want to add a whole bunch of Rust crates, which are like Rust's version of libraries, I define them in something similar to like a package.json that you might use with JavaScript. And then I say Cargo run, and it will do everything for me. Like Cargo run, I don't want to do more than that. Nice and easy. But then Cargo also has a formatter called, I guess, FMT, Rust FMT. But then if I do Cargo FMT, it will go and clean up my code. So for example, here's some unformatted code right here. And I can't even see what's at the end of the line. Okay, we got like a function call in here. And it just goes on and on. So if we format, here is what it will come out with. And we'll see this a little bit later. Rust has function chaining. You might have seen this in JavaScript. Several, like lots of other languages have it as well. But it's a really it's a really great pattern for functional programming, and it's a really great pattern for like builder. It's really great for the builder pattern. And so we'll explore that a little bit later. But just getting used to a lot more stuff being line after line after line. So anyways, that was a digression about formatting, but let's take a look at functions. Again, I have a little bit of stuff here about Rust by example, so you can take a look at that. It describes how to do Fizzbuzz, and I also, in the next little sample down here, like that the practice part is writing a function that can handle Fizzbuzz. And so let's take another look through here. We have a main function. We're assigning start and end to be some numbers, 3 and 24. And we want to say, find how many odd numbers there are between this range. And so we're calling some function. We're passing in the start parameter and the end parameter. And for the print line, basically how it works is this first, not really capture group, but like target or whatever, is this part right here. Second one is start, and third one is end. So now let's go take a look at what count, odds, and range do. And so right down here, we can see, okay, we got a function. And again, as we read it, function with a name, count, odds, and range, has a start at some i32 and ends at some i32. And then this function will return an i32 itself. And so we have some count that's happening out here, some count variable. We make it mutable because we want to change it. And then we're going to go into a for loop. And we're going to use the same range notation where we have some start and some end. But we're going to do something a little bit interesting here. We're going to do ... like before, and then we're going to say equals. And so what this says is that we want the beginning to be inclusive, and we want the end to be inclusive. And so it will go all the way, in this case, from 3 to 24 and test both of those numbers as well. And then if I modulus 2 is 1, so if it's odd, then we increase our count by 1. And then, as I mentioned before, we don't need to add the return keyword. This is just a value at the end of the function, so it gets returned. And then it goes back up to here. So let's see what happens. So what we're expecting is that there's a certain amount of odd numbers between some range and another. And I mean, I could have picked a better example. To calculate this better, all you have to do is just subtract both of them and divide it by 2. And it's plus or minus 1, something like that. But we can see here, there are 11 odd numbers between 3 and 24. Pretty cool. A little bit of an example. And if you want to go and practice this yourself, essentially I have some assert equals down here, which will be like a little bit of testing. There are much better ways to do testing in Rust that are also first class, just like formatting. But this is just like a simple example that, I mean, it's not going to compile because I haven't defined some Fizzbuzz or is Fizzbuzz function. But you can try that out yourself. So in the previous section, we saw a loop that figured out if a range of, or how many odd numbers there were in some range. And we did this in a very iterative way. Well, we did this in a way that we have some counter on the outside. We have to go through a for loop and we have to count up and stuff like that. But Rust takes inspiration from a lot of functional languages. And so a lot of what we do can be reduced into working on iterators and then doing functional work on these iterators. And so, I'm sorry, my headphones just went out. I mean, you can still hear me, so it's fine. All right, perfect. So in this example, we have a bit of an odd statement, but I break it down here so you can go through and read what's happening. We'll do a quick walkthrough though. So we're saying we want some variable named count. It's not mutable, so it can't be changed later, but we're going to assign something to it. And so that's what let count is. And we're going to start at some number, and we're going to go all the way up to and include some end number. And then this syntax is, again, a little bit interesting. This is where the idea of function chaining comes in. We do this, then this, then this, then this. And it's very nice because if we want to do more processing with this data, we can very easily add more of these function calls as we go along. And so what we're saying is that with this range, we're going to start by turning it into an iterator. And the idea behind an iterator is that we just have this range of numbers and we can go iterate from one to the next and the next. And we can always ask what the next is until it's over. But we don't actually need to ask any of those questions because once it's an iterator, it's more of like a concept that we can work with. And so what we're saying is with this iterator, we're going to do a filter. And so anything in this iterator, if we can, we take a closure and we're going to run some function. If this function returns true, we're going to keep the value. If it returns false, we're going to get rid of the value. And so if we're looking at the numbers between like 1 and 10, this checks if a number is odd. And so we'll keep the numbers 1, 3, 5, 7, 9, and we'll discard 0, 2, 4, 6, 8, I guess 10 because it's inclusive. And so once we've filtered it, once we've gotten rid of all the numbers we don't care about, we're going to count how many are left. And this is the same function as above, but we've been able to do it in a much more concise way. We don't have to define some count ahead of time. We can do it like so. After working in this way in a while, it's become a lot easier to think of problems through this scope of how can I take some iterative problem that uses for loops and turn it into a set of like maps and filters and just constructs that allow me to deal with going through iterators. And also, I should mention, if you know functional programming, Rust iterators and these types of functions are lazy. And so if I'm able to figure out what I'm trying to find before I get to the end, then I can stop asking questions early. So an example of this is like, if I want to find the first prime number that is divisible by all of these other numbers or something like that, I can have a range that starts at 0 and goes to infinity. And then once it finds the answer that I'm looking for, then it's able to break out and just return that. So I went through that pretty quickly. We have a larger explanation down here about how this sort of works. And so after the workshop or right now, if you have any questions, of course, feel free to ask them in chat. And you can also just read through this to understand it. Now, as I mentioned in the talk at the beginning, Rust is very good at working in parallel. And so we have this code above is not in parallel. It's doing everything separately, but we also have this very similar thing, or this very similar block of code. The only difference here is that we add into like par, so into parallel iterator. And then suddenly this will take this problem that we have and scale it up so that it's running efficiently on every single core or every single thread that our computer has. Now, this isn't, so the core Rust standard library is very nice and lean. It doesn't have a whole bunch of extra functionality for stuff like random numbers and async is now in the standard library, but it used to be like you'd use another crate called Tokyo. And in this case, to do a lot of parallel programming, I'm using a crate called Rayon. And so Rayon is super cool. It makes it very easy to do iteration on simple iterators. And so for this example here, let's say my start was 1 and my end was like 1,000,000 or something like that. Now, this function where it tries to find even and odd isn't a really great example. But if I had like a bigger question, like maybe I wanted to see which of them are primes, that's something that, of course, like you can use like sieves to do more efficiently. But let's say that at each number we needed to go and test every number below it to see if it's divisible by it. Then being able to split this up into different cores is pretty great. And so next up, we're taking a look right here at what some of this parallel code now looks like. Also on the playground, we have this cool, look, we can go in the tools, we can use Rust format, like I was talking before. It's already been formatted as far as I know. This line is quite long, but if we added some more, actually, let me just, what I can do is just go like this. And now this is a little bit easier to read. We can read one thing after another. So this is the same iterator statement that we had before, where we're just checking which numbers are odd, but we're using into pair iterator. We've also included Rayon. And so the Rust playground, it includes the top 100 most popular crates for you to use. And so I can just import it like this. We'll take a look in a second how this looks on, like if you start your own project. But here I'm able to answer the same question. I'm able to find how many odd numbers there are between a certain range, and I'm able to do it on multiple cores. And so this right here, it will give us at the end, it will also tell us the number of cores that are available on this this server that it's running on. So if we take a look here, we'll see what happens once it compiles and runs. So it will give us the same answer that we expected, and we can't see that it's very much faster, but we can see that it was running on 2 CPUs. And on my computer, I have 16 threads, so this number would say 16. I don't know how fast it will. Let's try like between 3 and 24 million. And of course, what we're asking it, again, very easy. But it should give us a little bit of example. Yeah, okay, so right here we can see compiled in 4 seconds, doesn't tell us how fast it ran. I could add something in that, like just did a simple timer, but we won't worry about that too much. And so I was able to iterate over that pretty nice and quickly. And I'm trying to think, I don't believe there's any compiler optimizations that would just figure this out right away. There might be, but I don't think so. All right, so now we're at the end section of what I have for like this workshop that you can try out. Now, as I mentioned, at the bottom of this document, let me just zoom out a little bit. There are a ton of resources that you can go into and learn more about. So we have the Rust book, and this is like the de facto place that you go to read through like how to understand different parts of the language. It gives you like a very good entry to a lot of the topics, and we can actually see here like the different chapters. So we've covered like a lot of the basic programming concepts. My favorite chapter in the entire book is the understanding ownership chapter, and that's just because it describes the idea of Rust ownership, how it works. It gives you like a very good view of the stack and the heap and why, like what you have to consider while you're working with them. So very good read. A few other resources. A Gentle Introduction to Rust is like a similar way of going about learning Rust. Is just a different approach. Rustlings are a set of exercises that you can do where it will give you some code and you have to figure out what's wrong with it to make it compile. Cheat.rs, this one's pretty awesome. Like in this page, it just gives you like a cheat sheet for everything Rust. It's pretty long. Actually, let me open it here on the side. I can like, so let's say we were talking about control flow. So in here, I can very easily see, okay, we got the while loops for, and it just breaks down everything, gives you a nice explanation, gives you references so that you can go read more documentation about them if you want. Beautiful resource. Exorcism. This is one that I really like because it allows you to go and do practice questions about Rust. And then when you submit them, mentors will actually come and look at the code and give you feedback. And so I've mentored quite a few of these questions myself. And what I really like is that when like it will throw you in to solve a problem that you might solve with a for loop in some other language. But then it goes and like has the mentors explain to you that like, okay, well, if you solved it with a for loop, what can we do instead to use iterators? and what resources can you look at to get used to them. But when I go and solve a lot of coding questions myself, I do like Advent of Code in Rust, and this has been like a great opportunity for me to practice a lot more, like thinking in terms of iterators and not necessarily have to solve everything with for loops. Rust by example, we've used them quite a few times in this workshop already, so you can take a look at how a lot of sort of like Rust concepts work, but from the perspective of showing off examples. RBXyet, I'll discuss this in a bit. There's some resources down here that are great to read. And then the Rustonomicon. And so I wrote, like, if there was a dark arts class for Rust, it would use the Rustonomicon as its textbook. And so we've talked a lot about how Rust is very safe, how it gives you memory safety, how it gives you all of these guarantees. But in Rust, you are allowed to use a block of code, or rather, you can make a block of code that is unsafe. And so in this case, the borrow checker doesn't fill all of its guarantees with it, and you can do things like double free and like all of this dangerous stuff, but it gives you a lot of power as well. And so while I've never written any unsafe code myself, I've so one time I was trying to do linked lists in Rust, and linked lists are very, very unsafe. And so I thought that I would be able to solve the problem by just using unsafe, but it made the problem more complex. And so then I just found some other data structure that worked way better for the problem I was trying to solve. So Rustonomicon, very cool. It talks a lot about how the compiler works, a lot of the stuff. I wrote this in because I was probably thinking I was writing inside of a Rust playground, but I just appended it to the bottom of the document. So I'll get that removed later. Okay, so this is like the general overview of the workshop. Feel free to go back and take a look at any parts of this later. I do want to mention that if you have any questions about the workshop, please reach out to me on Discord, on Twitter. My names there are like Angel on Fire, so you can check that out. But we'll dive back into the presentation a little bit. And I want to actually, before we do that, let me change my screen. So we're going to go to Big Picture Forest for a minute here. I'm going to go to my VS Code. Or am I? Rust Workshop VS Code. Okay, this should be it. Awesome. Okay, so we got it going on here. Let me just get rid of this. I'm in just like an empty folder. We're going to take a little bit of a look here at what Cargo does. I'm just going to toss my terminal up here so that we can see a little bit more. So I'm going to first start by making a new Cargo project. Currently, I have nothing in this folder. So let's go Cargo. Thank you very much, David. Good friend of mine. We can see Parliament in the background of his picture there. Parliament of Canada, that is. So Cargo, new Rust workshop. All right, so this is going to create a new Rust application for us. It's a binary application by default. If I wanted to make it a library, I would just specify lib. And libraries are nice because, you can put them up onto crates.io, which is like if you know NPM, or I guess, what's that? NPM.js, whatever like the node package manager website is. It's very similar to that. And so I'm making a binary, so I'll be able to run it. If I go look, this is basically my entire structure right here. I have like a cargo.toml. Let me just go like this so it's nice and big. So I got a cargo toml. And as I mentioned, this is where I store my dependencies. And so let me just go and bring in Rayon. So I'm going to bring on Rayon. So this is what I was using in the like the workshop demo. And so I have to import it here. But even though this is like a library that I'm bringing in externally, a crate that I'm bringing in externally, I don't have to do anything special to build it. Like I just go cargo build, or cargo run rather. Could not find cargo toml. Let's go into the folder first, and now let's try cargo running again. All right, so it's gonna. I didn't even need to download Rayon because I already have it from other projects I was working on. It compiled pretty nice and quick. I had to do like some other stuff here, but then when it ran, hello world. If we take a look at the source code, nice and easy, hello world. I'm going to make this a little bit smaller and breaking down a little bit more anatomy. The target folder, this is where all the debug stuff goes. This is where all incremental builds go. The git ignore standard. Cargo lock, similar to package package.lock, package.json.lock, whatever it is in JavaScript. Locks all my dependencies of everything. And there's quite a few libraries or different crates installed in here as well. Whenever I want, I can add a lot more dependencies. Pretty nice and easy to get them set up here, and then I can go to like crates.io and find stuff. And so like when I start, let's say like a web project in Rust, what I'll go do is I'll like type in the name of something I'm looking for. So maybe I'm looking for like a backend web server, and then I can look on crates.io and find stuff pretty nicely, then go find out more about it. But let's just copy some code over from the workshop. So this is just like a direct copy and paste of what I had before. Oh, what's this going to complain about? Type annotations needed for. Okay, so. Oh, and I also need num CPUs. I don't think I can. See. So let's do num CPUs. That's Copilot working. That's nothing special. 1.13, I guess, is the latest. So we'll just use that one. So back here, this will be happy. Rayon's included. Let me just bring over this code just like this a little bit. Okay, so same thing as before. Now, as for the IDE experience, and so I'm just using VS Code. I'm using Rust Analyzer, which is like the de facto, well, it's not currently like the main language server used for Rust, but when in VS Code, it's definitely like the one that's used by most people right now. Maybe. Okay, so like if you look at extensions, I'm gonna go Rust, then we're gonna have numero uno Rust right here. This uses a Rust language server. It's slower to use than Rust Analyzer, but Rust Analyzer, nice, very cool. All right, so as we notice, there's quite a lot going on here. I can like do like a run of the code. It will annotate for me, like if I haven't specified that 3 is an I32, it will automatically annotate what the compiler is going to assume it's going to be. And then as I'm doing function chaining, it will tell me at the end of each line what the current type of that value is. And so I can see that this is a range exclusive and it uses an I32. I can see that this is now an iterator of I32s. Then the filter, it just annotates everything nicely for me here. And so if I go cargo run, so as I said, I have 16 threads. Oh yeah, now we're using 24 million. So like I32, so it's gonna probably, if I go here, so I32, because probably I've annotated somewhere that it needs to be an I32, or maybe not. Maybe if I just go I64, now everything else is turned into I64, so we're good. So 24 billion is a pretty big number. My 16 threads, let's see how they're holding up. So yeah, my 16 threads are getting pushed pretty nice set of boundaries here. And so the compiler obviously didn't optimize this, because if it did, then it would just be able to make a very quick assumption about what it is. And again, like each core here is using like 86%. So what this would suggest to me, since it's not using 100, and actually I'm streaming, so I probably shouldn't be doing this. I don't know if it's like killing the the stream at all, but so what it suggests to me, because we're only using 88% of the CPU, is that this problem is spending more time trying to spread work across the threads. And so maybe like if I made sure that each thread had more work to do on each one, so maybe either test 5 numbers at a time, test 10 numbers at a time, or it's suggesting that the overhead of passing the threads is significant. All right, now so this is going to run. Don't know for how long. I'll stop it for now. But what we can do, I'm trying to think, is there anything else? So okay, so as I mentioned before, like if we have some weird stuff here, if I save, it's going to cargo fmt. I can also do this from the command line. So cargo fmt. Let b equal 10. So another example, cargo clippy. This is another pretty much first class tool that is actually, I don't know if it's built by the core team, but it's maintained as the primary linter. So this will complain to me once I've done something that is kind of dumb. And so in this case, I've created a variable that isn't going to be used, and the compiler is going to optimize it away, but it will still give me a word of warning. Clippy. So one thing about the Rust compiler is that it's very, very helpful. Let's take a look at an example of where it's going to complain because of the borrow checker. So let a equal test.to string. Rust has two string types, one on the stack, one on the heap. This one is going to be on the heap. Let b equal a. So what I'm doing here is I'm making, so back to ownership. A is now a string, and this value is owned by A. When I say b equals A, now B owns that value. There was no deep copy on the heap. Instead, ownership is now passed to B. So now if I try to say print line of A, now when I, cargo just run, it will give us the same thing, but let's take a look at what this says. So B is unused. Let's get rid of that because that's not the main thing I want to care about. Let's get rid of this because I don't want to care about that. So we're going to get a compile error here. Borrow of move value A. And so what this says to us is a move occurs because A has type string, which does not implement copy, which means that since it's on the heap, it doesn't automatically deep copy itself when you try to move it. And right here, we have a move. We say underscore B is equal to A, and then we try to use the value after a move. And so the compiler is very, very good at telling us what's happening. If I needed more information, I could go and just do this, and this will tell me a lot more about the error, give me a lot more detail about it. And we're running low on time. I want to show off cargo docs, but I want to also show off some more community stuff, which is pretty cool. So we'll go back to Big Forest for a second, and we'll go to share my screen, my Chrome screen. Where is it? Google Chrome. Cool. All right. So we're close to the end of the presentation. I want to talk a little bit about the Rust community. Where is Rust? What's it up to? Whenever you have like this new language come out, it's fun to use new languages, but really the big thing that you want to care about is like, well, can I use it in a production setting? Can it solve this problem for me? Will it be used down the road? And so we can take a look at the Rust Foundation. Rust Foundation, I think it started like it separated from Mozilla to become its own foundation, like early 2020 maybe. But we can see like some of the founding members of the foundation. So people who've like donated a lot. We have like AWS, Google, Huawei, Microsoft, Mozilla, Meta, Platinum, very cool. Then we have like a lot of other companies that are also investing in Rust. And so these are companies that have paid like a certain amount, donated a certain amount to be listed here. But there's definitely some very significant names. And we can also see, so I want to show this off. So this is a friend of mine who works at AWS, works on Prime Video, just released this blog post January 27th, so a few days ago. And it talks about how Prime Video has recently started using WASM on its front end to serve video content much more quickly for people. And so it's a great blog post. If you've been in the workshop file, you can access it through there. And it talks about how, like, just numbers wise, average frame times went from like in the mid range went from 28 milliseconds to 18. Worst case went from 40 milliseconds to 25. Just a quick breakdown. We have like it used to be you would download a whole bunch of JavaScript to run on top of the JavaScript. I almost said JVM. The JavaScript virtual machine on the browser. But then with this like new way of using WebAssembly, a lot more of it is Rust that you can ship in WASM. And then you have like the WebAssembly VM doing a lot of the heavy lifting of like what rendering happens on each frame, whereas the JavaScript VM of whatever happens on the front end communicates, but like the WebAssembly VM will only listen to JavaScript when it's like a good time. So that like there's like a good transition between two. But anyways, great article. Alex Anna is one of the current leads of the Rust game dev working group as well. And so it's super cool seeing them publish this. And another part of Rust that I want to quickly go over is this idea of if we want to know if stuff is ready yet, maybe you're in the embedded world, maybe you're in game dev, maybe you're in whatever. There's a lot of Rust sites called Are We X Yet? And so in this case, Are We Web Yet? If you want to see if Rust is a good solution for web backends, web front ends, proxies, web servers, anything like this, this website gives you like a great breakdown of all of this. And so from here, I can very easily see in detail, like maybe I want to find out about binary protocols. So I can go here and find all of the Rust crates that are sort of doing this. I can't go back, I think. Can I go back? Home. And so this gives us a really great way to look at each ecosystem and find out more about it. So are we meta yet? This is a actually Mozilla has a better one. Are we yet? Okay, so Mozilla Wiki looks old. I'd love to have like a new version of this, but we can look at, like, for example, are we meta yet? We just looked at. Are we web yet? We just looked at. Are we learning yet? This is a pretty cool one. Are we GUI yet? So can we make GUI applications very nicely? So with learning, we can look into the sort of area here if it might have what we want. If we want to do GPU computing, this comes over into game dev quite a lot. So really awesome ecosystem going on there. Are we GUI yet? It talks about GUI interfaces. The one I work on, Are we game yet? I take quite a lot, or I do quite a lot with this community. And so AI, 3D rendering, entity component systems, very, very cool, by the way. Game engines, a lot of stuff going on here. But then it also shows off a lot of games that are made in Rust. And so if we go to open world, we can see Valorant right here. Yay. Okay, so a few minutes left in the talk. There's one thing I wanted to show off. Oh, yes. Okay, so this is a project that I worked on back during the Christmas break, during December of 2021. And so my friend worked on this super cool LED Christmas tree. Shout out to Aiden Crowther. Very cool stuff that he does. And he made this like 8-foot tall tree, has a whole bunch of LEDs. The dimensions are like 19 by 75 or something like that. And so I'm like, awesome that you have that, but I'd love to make something that can like render onto it. And so, for example, take images that are either like someone's turned from a GIF into an image, or just generate your own images and then show them on the tree. And so I ran like a mini hackathon at my university. There's like 5 people who showed up, kind of thing. But I'm like, hey, if anybody wants to try making stuff for this, I will make sort of like the thing that interfaces with the Raspberry Pi. I'll make the thing that allows you to visualize on your local computer how it will look, and you come in and just make cool looking things. And so the entire stack of this project is built in Rust with like a little bit of SCSS and Makefile. And the reason for that is I actually made a front end web application in Rust as well. So we can take a look at that, what the source of this looks like. So you have some HTML, and this basically just bootstraps the Rust project. But I'm able to write app.rs. I'm able to write Rust, and then this compiles to WebAssembly, and it runs in the browser. And so everything that I have right here, it has like this idea of cards, very similar to JSX and React, sort of. I have more HTML right here, and it creates this page right here. And so I'm easily able to, well, these are just images off Discord that I've linked, but you can kind of see what each of the renderers look like. And if I take a look at the web tools here and I refresh, we can see that we're getting a WASM pack right here. A whole bunch of WebAssembly, runs nicely in the browser. It's pretty large because I'm not like gzipping it. I'm not compressing anything. I'm not getting rid of extra stuff that isn't needed. But the size, I don't know, where does this say? Content length, so 366 kilobytes. And it can definitely be made a lot smaller. And for reference, the link that I was showing off about, where's my, right here. This right here, the WebAssembly that shipped is 150 kilobytes. That expands out after unzip to like 700 or something like that. But we have several different renders, and it's pretty awesome. I've also set it up so that there's a backend. So if I hit run, then it will send a request to the backend, and it will show off what or it'll start playing on the tree itself. Just to show a little bit more of this demo here, we have, okay, here's like a pretty cool example. So one of the other developers on Valorant actually came in and wrote Mario jumping up and down, and it looks pretty cool. And you think, oh, okay, this is pretty awesome. It's a cool GIF. But no, he went through and coded all of this with like some really, really complex, let me see if I can go Mario. Yeah, okay, so he went through and coded this all with bit shifting and hex. and all of this magic. And so it's someone who really knows. So they worked on like the world generation for Valoran, and so he knows a lot about this kind of stuff and using Rust and really abusing the system. But it's some real cool magic that's going on here. Yeah, so basically, this project has a web front end written in Rust, web backend written in Rust, an interface to talk with a Raspberry Pi. It has a visualizer. It's built with Nanu, so you can go and play around and see like what it will look like on your computer. And I've set up this sort of interface so that people can go and add their own if they want. And so this is what I did with the students at my university. I'm like, okay, well, you want to try some of this cool stuff? You can use this, and then I will integrate it with like the rest of the tree and stuff. Yeah, so that's pretty much it for today's Rust workshop. I'm trying to think, do I have, oops, Izzy. Oh no. Okay, do I have anything else? I think, yes, that is all. So thank you so much for letting me talk to you for an hour about Rust. Love doing it. Taking a look through chat right now, we've got, Param mentioning the Rust Foundation, founded very recently. Virtual hug, thank you so much. David mentioned got Rust working in like 20 minutes. Yeah, so for the examples that I have, I mean, they're like pre-coded and stuff like that. But it's definitely not hard getting projects up and running with Rust. And like, it's to the point where when I have some like scripting need, I'm starting to choose Rust more often over Python, because I can do stuff very concisely with like the iterator functions that I've described. I can handle stuff goes very fast. I know it's scalable from like a software engineering perspective. Like as I mentioned with memory safety is awesome, but the fact that Rust gets you to keep your code base in check really helps keep your code much more clean, like over time. And so this is like one of the other really big benefits of the borrow checker in Rust. Yeah, so thank you so much. I think like the links to the workshop should be available forever as long as Notion's alive. So do go check it out. Do reach out to me if you want to find out more about anything like that I do, about getting involved in the Rust community, about, as I've described, Rust is used at a lot of big companies. It's growing a lot. It's used in a lot of big industries. It's all like there's very few problems that it doesn't solve as well or almost as well as other languages. And so, yeah, it's a very exciting time for Rust for sure. So thank you very much.
Thank you very much, Forrest. I don't know what's happening to my camera. For some reason, I'm not visible.
All good.
So we have. So it was a really nice workshop. We got to learn about lots of new things. We got to learn about the iterator methods that you mentioned in Rust, and we also got to see how we can do parallel programming within Rust, which seemed to be very easy to do compared to the other competing languages. Now
Mm-hmm.
we have a couple of questions for you,
Yeah.
really interesting questions, including some trivia. So,
Mm.
according to you, what is the best thing about Rust?
Um, so a lot of people say like the memory safety, right? Because it's like the core feature. But to me, it's the community. And the reason for this is that when a language like Rust is built out in the open, the only way that it's going to continue doing so well is if there's a community behind it that really pushes the ideas of keeping everything inclusive, and keeping like really like pushing the envelope on what's happening. And so the biggest way that I see this, there's like the joke about one sec, I'm gonna like the Rust evangelism strike force. And so like the idea that like people who like Rust, they tell you about Rust. But then
Mhm.
the other thing that I experience is when I go and I'm talking to people that are better than me at Rust and they know more than me, there's not the sense of, oh, you don't know this yet. Oh, you cringe. You can't even do this in Rust. Instead, it's so like, it's let me show you the stuff that I find cool. And so I've been doing a lot of work with people like up the food chain and like the Rust core team, and like talking with a lot of people, going to a lot of events, meeting a lot of people. And even though there's people like right at the top who are like cores of like the language team, doing super amazing stuff at like the compiler level, like I still have conversations with them and they still find it interesting to talk to me about my experience. And so for me, my favorite thing about Rust is definitely the community.
I see. Makes sense. And I think the community is the reason why we have such a big foundation under the name of Rust right now, which is
Mm-hmm.
funded by so many huge organizations.
Yeah.
And you just showed us lots of examples in Rust, almost all kinds of applications, including front end, back end, WebAssembly included. In general, in the industry, what kind of applications are mostly made in Rust?
Yeah. Okay. And so I think right now, like if a company is going to go work on a Rust project, oftentimes it's not going to be to completely replace a project that they're working on, although that does give a lot of benefits. A lot of the time it's to introduce something new, where it's like we have a new product that we want to work on, and we're seeing that Rust is a very viable way to go about doing this. And then also Rust can interact with C and C++ quite easily through like foreign function interfaces. And so the ability to use Rust isn't just let's make Rust everything, but instead let's get Rust to tie into a lot of other stuff. And so Rust works very well as like microservices, API endpoints, tying into more core systems and stuff like that. But then I think the more interesting question is, what does Rust not do well? And so
Mhm.
there's a lot of work that's going on to solve these areas that is not so good at just yet, or rather places where there's a lot of C and C++ foundations that aren't built in Rust yet. So in game development, we see this a lot in the graphics side. So if you want to do stuff with CUDA, if you want to do stuff like interacting with the GPU, the foundations are still being built. And then on top of this, we're seeing a really big push for Rust in Linux, and so Rust in the Linux kernel itself. And I've had the opportunity to speak with some of the people working on this project as part of the like cross team collaboration fun times meetup. And so they've come and spoke. They gave a talk to the rest of the Rust teams about what isn't really great in Rust yet when you're trying to do stuff at this level. And it comes down to there's stuff that maybe doesn't optimize as well as GCC would when it gets to like at the assembly level. Also, how the Rust memory model doesn't necessarily line up as well with certain parts of C. And then I think one other really big place that Rust is still working is this idea of like a certified safe language. And so when you want to use a language in a mission critical situation, you have to have a compiler that is certified and has guarantees around it. And so we see like I think C++ is certified if I'm not mistaken, and then a lot of older languages like Ada I think is certified as well. So like if you're sending a rocket ship into space, you'd have to use a certified language compiler. But then
Mhm.
Rust is like really pushing forward on this front as well to get a compiler certified. And so there's a team called Ferricine that's working on this. And I'm super excited for that because being able to use Rust in mission critical situations, but then also getting all the benefits of the compiler is really great.
I see. Yeah, that's a really good answer. And you mentioned the introduction of Rust into the Linux kernel. We'll get back on that. A big struggle for people who want to develop very big projects in Rust is the compilation time, because it is very huge due to the error handling during compilation.
Mm-hmm.
I have been noticing that many big projects have been moving their compilation to the cloud. So, do you think that cloud compilation is the way to go for Rust?
This is a really great question. And so this is one of the largest issues that we, when working on Valorant, have. Because let's say you make a small little change to the code base, you can expect your compile times to be around 1 minute to 2 minutes. And so what this has caused us to do, especially for designers, is implement a lot more functionality so that when the game is running, they can change damage values and they can change how things look without having to recompile. Now that being said, there's a lot of effort going into increasing this compile time, or sorry, decreasing this compile time, but then also getting around this problem in different ways. And so one pretty recent game engine in Rust called Bevy is approaching this from the perspective of, well, if we're making a game engine, let's not introduce stuff in the game engine that will add more compilation time to your project. And so they have like a few steps that you can do to have much quicker compile times. Then as for cloud compilation, Rust is really great because by default, when you're compiling, it will use as many to compile like all the sub libraries and crates and all of the other stuff. It will use as many cores as you have available. And there's a really
Mhm.
cool Rust like breakdown ability that you have to see like how much CPU usage is going through your entire compilation. And so what happens is during the initial compilation phase where it's making all of the object files, it will max out your CPU, which means that if you're in the cloud and you're using like some 64 core system or something, that part's going to go really fast. But then what happens is that right after that, you have the linking phase. And during the linking phase in Rust, when you're doing release builds, it does a lot of optimizations into like the LLVMs doing optimization. So it's speeding up your code, it's taking functions and inlining them if it needs to. And a lot of magic happens here. And this is not something that can be done in parallel. And so we've
Mm-hmm.
seen in recent months that there's this new linker called Mold, made by the same person who made Gold and LLD, I think, or something along those lines. And it's really good at linking programs in parallel. But the problem with Rust is that linking the program isn't the big part. Link time optimizations, that's the massive part that can't be parallelized. And so I would love to see improvements on this. And I'd also love to see more functionality around, if I'm going to go hit compile on my code, sending all of my code to some server to compile and then sending the binary back to me. I think that's a great way to go. And I'd love to see that explored more, because like definitely the cloud, or rather computer CPUs are really good at doubling the amount of threads that they are. They're not as good anymore at increasing clock speed. Or I mean, actions per cycle or whatever, like that's still increasing. You're still getting like SIMD stuff, but we're getting a lot more threads. So if we can do stuff in parallel, this is where a lot of the future of computing is going to go. So concurrent programming, distributed programming. And I think a lot of Rust's primitives really allow for safe handling of this.
Mm-hmm. And for Valorant, I think you mentioned that you have a self-hosted runner that you use for building the application
Yeah.
whenever a new release comes. So, can you share the specifications of the self-hosted runner?
Absolutely. And so I will mention with Valorant, we do have like a dev blog. I've been writing this dev blog for like 156 weeks in a row now. And so there's a lot of really great data that if you go search on there, there's not really a great searching feature, but you can like find out a lot more about like what I'm about to say. But we love talking about this type of stuff, because since we are an open source project, since we do a lot of self-hosting ourselves, especially for continuous integration, we have some requirements. And so when Valorant is compiling, especially for release builds and doing some of these optimizations and stuff, we see a max amount of RAM usage around 10 gigabytes. And that means that our continuous integration runners need to, like, for each runner, it needs to have that much available. And so on my home server, actually, wait, can you share your screen again? Let's just screen it again for a second.
Yes, please.
Valoran grafana.valoran.net. Okay, so we have exposed different. I just want to pull up my local Grafana as well. So I love showing this stuff off, because we expose it to the public, but we can see how many different, like how many players are online at once. We can also go into the game server and see like, okay, this is the number of players. This is how like the server tasks are going in Rust. This is how much CPU is being used right now. So we're using 16 different threads. And this is how much usage is going on right now on like our main game server, how much networking is happening, all of this really great data. On my home one, let's go browse to my node exporter full, and let's change from this computer over to Valorant. And so this is sort of what my CI server at home looks like. And so it's pretty powerful. It has 93 gigs of RAM. Most jobs, when they happen, they like, for example, this is taking like 20 gigs of RAM. And so I have the main runner that's used for production builds. And so when we're releasing stuff for people to actually play, we only use runners that are run by like the core team. And so we can see like CPU usage here. If I go to like the last 7 days, maybe let's see what we have. Actually, it's going to take some time. It's probably going to die a little bit. Okay, but so 4 spikes. There was one spike that happened right here where maybe it was doing like 5 jobs at once, and it looks like it was using like 30 gigs of RAM to use. Oh, and then like, yeah, right here we can see there's like a spike of CPU usage a lot. So let's zoom in on there. Take a look here. We can see like some jumps here. RAM's going up to like quite a lot used. And so my runner is like the most powerful one we have. And it's just this 2 CPU server I have running in my basement. I'd love to show it off. It's like right behind the door right over there, but I can't grab my webcam super easily. But then we also have a lot of other volunteers who come in and bring their own hardware. And so for a lot of people, it's like they can run 1 or 2 runners. And then this just means that when someone pushes code, it gets tested pretty easy. So if I go Valorant GitLab, we could take a look here at, so we use GitLab as our main product place. And the main reason for this, and the reason we don't use GitHub, is because GitHub large file storage is not free. in GitLab it is. Like GitLab, they say that they're storing 270 gigabytes of storage for us, and we like that because GitHub would charge us for it. And so everything else GitHub I love though. It's just that for this use case, it's not as good. But if you take a look here at the jobs, so 4 hours ago, 5 hours ago, jobs are running. You can see like different pipelines. And so, for example, if someone pushes some code, then we have like a lot of different jobs that run. And so, yeah, for the workflow that we have, a lot of our stuff is self-hosted. Our main game servers are hosted in Hetzner in Germany. So yeah, some pretty cool stuff there.
Wow, that's really interesting. And and the tools that you mentioned right now, Grafana included, really interesting DevOps tools. I think we have had workshops on them previously by
Mhm.
other members in our community. There's a question in the chat that says, since most of our learning usually happens through open source project development, are there any existing open source projects in Rust that we should look forward to contributing to?
Yeah, so this is a really great question. Um, a lot of so first of all, because Rust has this crate system similar to like Node, there's a lot of different crates that solve different problems. And so whatever you're interested in contributing to, there's definitely something out there. And so I'm wearing my Hacktoberfest 2021 shirt here, but for 2020, I actually contributed to a Rust project that was they're writing a JavaScript engine in Rust. And what I specifically went and did was went into the parser. And then if you have like two semicolons in JavaScript, like that's allowed. It's basically just an empty statement, but the parser wasn't handling that properly. And so I went through and I made some changes, and it was really cool because I didn't know anything about the project. I didn't know how the JavaScript parser would work and stuff like that. But I like they helped me through the process of understanding what I needed to do and solving this problem. And so that was like a great experience for me. And now when I want to go out and find projects, I first of all get excited by stuff that's happening in Rust. And so one of the things I've gotten excited by recently is a new ORM, like database ORM, object relational manager, called CORM, SEA-ORM. And this is a query language that's built in Rust for relational databases. And it allows you to model data in Rust structs that then transfer over very nicely into the database relational model. And I really like this project because it allows me to go write database schemas in Django, which I know like inside out, and very easily import them into Rust and have like type safe like management of the database data, which is amazing to me. And I'm like, this project is so cool. I went onto their Discord. I'm like, hey, can I try something out? I went look through their issues. I saw one that was like, actually, I saw like a pretty complex one. It was like the way that they generate their files that allow you to interact with the database. It uses like Rust macros and procedural macros, and so code that writes code effectively. Very cool stuff. I didn't know how to do any of that, so I went and like looked up some tutorials, and that was like a really cool way to learn about that. But then I went through and just did some cleaning of code, and so they were doing some error handling that wasn't like, it was good to get up and running, but I'm like, this could be handled better, more clearly, and so I went and made a PR for that. And so I think really finding out what types of things you want to work on, and then going to like awesome lists and just seeing like what Rust projects would be cool to contribute to. And so there's a lot out there for sure that's being pushed right now, whether you're into web, whether you're into game development, machine learning, math libraries. There's so much happening. And so for starter projects, I mean, I always recommend coming and checking out Valoran. We're always working on making our like new contributor workflow easier for people to get started with and get introduced to like parts of the team and stuff like that. And so this is definitely like what we strive for, but a lot of other Rust projects, like there's very few Rust projects that I've come across that haven't been a good experience to contribute to, I think.
I see. I checked out all of the names that you mentioned, and I posted the links in the live chat so that people
Perfect.
can check them out.
Absolutely.
You mentioned that Linux is soon going to have Rust components written in Rust. So the existing kernel, which is written in C++, will not change. It will remain in C++, but we will add to it using Rust. So that means that essentially we are writing code in Rust for an existing C++ code. So we have these three languages, C, C++, and we have Go, and we have Rust. These three are the most popular low-level languages used in system design right now in the world. So just Just understanding the fact that Rust and C++ can cooperate to develop the kernel, do you think the three languages can interoperate in applications?
Yeah, so I really love this question because I see it from a lot of different angles. I don't know too much about how the kernel actually works, but from what I've heard and from what I've read, it does make a lot of sense to use Rust in very specific places in the kernel where you're introducing different like new modules or some functionality that isn't necessarily rewriting C++ everywhere, but it's adding new functionality just in a safe way. And so I know from what I've heard, a lot of the work here is taking the tool chains that are required to compile Rust to get it in and making sure that this works well with the current ecosystem. But then there's a lot of skepticism as well, right? Like the idea of introducing a new language to Linux kernel, it's very disruptive. There's a lot of reasons that it shouldn't be done. And so, I mean, at the very least, the idea that if you can find any code in like that when compiled in Rust doesn't run as optimally as when it compiles in C, then that alone is a reason. And so there's a lot of different people working on this problem because the end goal of using Rust in this type of area is that the benefits you get from memory safety will help you down the line at not running into as many 0 days, as many bugs, as many security vulnerabilities. And not only like the kernel is really awesome, but then there's a lot of stuff being done around externally as well. So for example, there's a project that's replacing or rewriting all of the Linux core utils. And so as far as I understand this, this is like I think it's stuff like ls and like just commands that you'd run in like the shell. I could be mistaken about that, but they're already showing that a lot of the ways that Rust can handle this is like a lot faster than alternatives. And then another thing that I really like is other languages like other tools like ls being rewritten with new functionality. And so we know we use ls to like search folders, but it's like a very old tool. We know a lot more about how we want to know about folders. And so there's this project called exa, and it is very similar. Works pretty much the same when you're using like the different options and stuff like that. And it gives you like a better view into stuff right off the bat, gives you more information. And essentially, like I've been able to replace a lot of my standard tools. So I use htop, and like when I was showing some stuff off, there's like another Rust one called bottom, which is like super useful. And there's like a lot of other tooling. And so I think that yeah, when it comes to replacing stuff in the kernel, Rust is definitely a good candidate for that. I think with interoperability for stuff like Go is more difficult because Go is garbage collected. And so as soon as you start using it, you run into performance impacts and stutters and stuff that is not ideal. But that being said, I do a lot of cloud work as well. And so a lot of stuff with Docker, a lot of stuff. I tried learning Kubernetes and I find it very difficult. And so I like the HashiCorp products instead. So like Nomad, Console, this kind of stuff. And a lot of these applications for cloud are written in Go. And I think that Go has been a really great language for this because interoperability between Go projects, building this foundation on Go is a lot more command line interface based than it is performance critical. And so,
Mhm.
and also there's obviously a big argument between like performance on other languages. Go is very fast. I'm not trying to say it is like worse than Rust in performance. There's a lot of debate around that. But what I do like is that I think interoperability between Rust and Go stuff is growing because Rust is starting to evolve into places and solve problems that Go is also solving. So a lot of space in cloud. Like I recently joined the Rust cloud native group. I didn't join like the working group, but just like their Discord, chatting with them, seeing what they're working on. And I love the idea of Rust being used in like a lot of cloud areas. But Kubernetes is Go, Docker is Go. Like all HashiCorp stuff, like pretty much anything for the cloud, it'll probably be written in Go for the time being. And so as we move a lot more of our systems to the cloud, and as we start looking into how services run in the cloud rather than how programs run on our computer, like of course, like there's a lot of research being done in a lot of different ways, but I think it's definitely a very exciting future to see like both Rust and Go be taking over.
Mhm. I agree with you. There was a time I tried contributing to a key value store service created in Rust, known as Titanium KV, which
Mm.
is an open source project incubated under the CNCF Foundation. And my biggest struggle, so I really don't think that Go builds might be more efficient than Rust builds. But the struggling part was the fact that it needed a 40 core machine to compile. Um,
Yeah.
in a short amount of time, and I tried compiling it on my machine, and it took a very very long time compared to Go. So I think developer experience is one of the reasons why Go is leading the cloud industry compared to compared to Rust.
Yeah.
And in all these system design languages that we just discussed, in C we have absolutely no error handling. We have to do all of it ourselves. In Go as well, we don't have any try catch or error handling syntax. We just have return values that allow us to analyze if the error is nil. uh, uh, so in Rust we have a totally different kind of error handling, which is very similar to the promise catch syntax in JavaScript.
Yeah.
What's your opinion of error handling in Rust?
Yeah. So I really love this question and some of the things that you mentioned before. So are you able to share my screen again for a second?
Yes,
Um,
yes, please do.
there's this repo called hello-world.rs, and it's just like a big mockery of like Rust compile time and everything like that. And so it talks about how you can do hello world in Rust in only like 1092 dependencies, and then it has like a lot of stuff here at the bottom that like makes fun of like, or like just Rust sayings like um just like a whole bunch of stuff making fun of like compile times and like I don't know. It's hilarious to read, and it like to build this version of Hello World, it takes like 3 hours or something like that, and like it maxes out all your cores while you're running. And obviously, it's just a joke about how you have to like include a lot of stuff and how compile times are big. But as like a Rust developer, it's absolutely hilarious to go through this repo.
Mhm.
But that being said, we have to remember as well that one of the big promises of Rust is that as we like if our code compiles, it probably runs. And so what this means is that we're not going through the loop as often of compiling. Writing code, compiling, and then airing out when the program's running. And so instead, it's compile, get a compiler error, and then fix all the compiler errors, and then it compiles. And then when we think about how Rust compiles and where it throws errors while it's compiling the code, not while it's doing the linking and optimizations. And so this means that it will often, the compiler errors will happen very quickly. And then on top of that, you can run extra stuff. So for example, like Rust Analyzer, it runs while you're coding. And so it tells you problems that you'll be able to see before you compile. But you can also run cargo check, which doesn't actually compile any of your code. It just runs checks on all of it. And so these are really great ways to make sure that while you're going through the iterative process of fixing your code, removing errors, making the borrow checker happy, then once you get to the point that it compiles and you are testing, you're much more likely to be fixing your logical errors in your code, which I mean are also harder to make because of memory safety. But then on the yeah, so that's like what our process looks like. Now, as for the question that you just asked, though, I feel like there's like one more thing I want to say. What was the question again? Or if you just pop up like the prompt here, I think that would. Oh, sorry, and you're also muted. Oh yes, error handling, perfect. So error handling in Rust, one of the really big things is that in Rust is very difficult for your program to crash by accident. The only way that your program is going to crash outside of a compiler bug or something is, so first of all, we can't segfault. When your code is running, like we've already had all the borrow checks and the compiler checks, and while I'm going through and writing my code, anytime that there is anywhere that could potentially go wrong, then I must handle it in some way. Now there are some extenuating circumstances to this, but essentially, let's say I'm trying to parse a number from a string to an integer, then I have to say either if this doesn't parse, this is how you should handle it, or I could say unwrap. I can just say like, well, whatever comes back, then I'm fine. Just if it's an error, then you're gonna make the program crash, and that's fine. And so error handling in Rust, there's like these this concept of results and options. And so when I'm doing something that might give me an error back, then I will get a result object. And this result is an enum. It can either have so it's not sum and error. It's I forget what the data side of it is, but the one enum variant can be the data that I was expecting, and then the other enum variant is an error. And if I
Mhm.
am properly testing, if I'm matching across these, then I can say, okay, well, if this is something I expect, then I can operate as normally. If it's the error, then I can handle this properly, or I can propagate this error back up the stack so that I get a proper backtrace. And so,
Mhm.
error handling in Rust, it all comes down to this idea of potentially adding more time to what I'm doing up front, the ideas that I'm putting in so that I make the borrow checker happy. But then I get massive returns on my investment because when I'm running, my program is not going to crash for a lot of default reasons. It's only going to crash if I make mistakes on how I'm handling errors. And then I can be like a lot more confident that my developer process is iteration on my code, not iteration on debuggers that
Mhm.
are when my computer's crash or when my program's crashing.
Yes, that is a really nice answer. Thank you very much for that. I think I personally love the way Rust handles errors. I think it's a really good trade-off for the longer compilation time. And most of the times I have worked with Rust, I have found it really comfortable, which is why I think Stack Overflow says it's the most loved language in the world. So moving forward, we have some trivia questions for you. I already know answers to some of them. I think the viewers might be interested. So, why is your username Angel on Fire?
Yeah, so this is definitely a great question. Pretty big backstory, but essentially what happened is I used to play Warcraft 3. I played a lot of custom maps. There's this map called Demonic Sword, and it's like this RPG that you could play, and you could save your character. So like every time you booted, it wouldn't just be a new map. And I really like this game. It had a town called Fyra, and so I based it a lot on that. But then also before that, my friends and I, when we played together, we had three different usernames. So in Warcraft 3, you have the Night Elves, humans, orcs, and undead. And so one of my friends was the Angel of Death, one was the Angel of Life, and then I became the Angel of Night. And so essentially, I just swapped out my name, Angel of Night, for the Night Elves. I swapped it over to Angel on Fire. And so this
Mm-hmm.
is what I've been using for quite a while. And I like it. It's like a pretty colorful name. And then also, when I'm in online communities, it makes it like really like some people have like complex names to mention and stuff like that. So when we have like our meetings on like Valorant every week, we have like we call each other by our online usernames and stuff, and so it's a lot easier to like say Angel than like a lot of the other usernames and stuff like that. So I think that's what I tend to. It's quite a nice username. I like it.
Mm-hmm. Makes a lot of sense. When I first heard about Angel on Fire, my first guess was something related to fire code, but that
Yeah,
ended up not being the case.
yeah, yeah. I think there's definitely a lot of things that it's sort of related to. Um,
Mm-hmm.
but yeah, I'm someone who doesn't use ligatures in my code, and so I have
Uh-huh.
like all the simple fonts installed.
The simple monospace fonts.
Hmm.
Now that we're talking about naming things and nomenclature, why was it named Valoran?
Yeah, this is a really good question. So historically, um, I don't know the exact reason at the beginning. So the Valoran is based on or not really based on, it's inspired by a game that came out in like 2012, 2011 called Cube World. And it's
Mhm.
like this open world game, voxel graphics, adventure based. So it looks like Minecraft, but you don't go mining, you don't go building. And so
Mhm.
we're inspired a lot from this project, but in coming up, well, Valorant itself started on Reddit by someone saying on the Cube World subreddit that it'd be cool if we could make our own community version. I don't think it'd be that hard. It'd be awesome to try. And so a lot of people really like that idea. And I don't know when the exact name was chosen, but in German and Dutch, Valoren means lost. And so
Oh.
it's not there's like extra L in there, and so I don't know how it changed from Valoren to Valoren or something like that. But that's like I think the general inspiration from it. And then also just it sounds pretty nice. Now that being said, though, we picked like this was our name from the like mid 2018, and then
Mhm.
Valorant, which is like a new shooter game, it came out in like
Yes.
2020, and so everybody conflates the two of them, mixes them up, and uh, I think for us, it's definitely going to help us in the long run to. So we have a name that's similar to Valorant, and then whenever we upload videos on YouTube, it automatically categorizes them as Minecraft. So I
Mhm.
think we just get like
Ah.
boosts from PR by accident, which is pretty cool.
Mhm. That's nice. So it's like getting lost in a world of blocks.
Exactly.
Valorant.
Yeah, it's like the adventure sort of feel. Yeah. So really capturing that dynamic for sure.
Hmm. So you're a very big Rust developer, long time user, very big fan of Rust, and you do lots of talks on Rust. So this is going to be an interesting question for you. If you could change one thing about Rust, what would it be?
Yeah, so I think this one's really cool because although I give a lot of talks on Rust, and although I'm part of a lot of projects and I like run like these different meetups and stuff like that, there's still a lot about the language that I don't know. And so, for example, although I use Rust for advent of code a lot, and I'm really good at like the algorithm side, I'm really not so good at the software engineer side. And so I've only recently used traits. Like, so Rust traits are similar to Java interfaces. I've only used traits for the like first or second time like properly on a project like a few weeks ago, and this is like a pretty standard idea in Rust. And so I definitely think that this is what comes back to like the idea of community, that I don't necessarily have to be the best Rust developer to be able to make a lot of change and do a lot of really cool things in the community. Now, as for what I would change, this one's a bit more difficult because I haven't gotten to the point where I'm like low level enough to know what differences there should be. And I think as I experience different things, I see that there's a lot of ups and downs about um, different parts of how teams operate, how working groups operate. And I think whenever I see something within the domains that I work on, whenever I want to see something change, like I wanted a community event that allowed people to come show off what they were working on. So I made a meetup, and that's like for me, I just do the change that I want to see. Um, I think yeah, I don't know, because I've been exposed to like a lot of the current issues of like where Rust is like working on doing better. So for example, one of the big ones is like error handling. Um, I know that there's a lot of reasons that Rust error handling could be done better, and like how things could change up and how things could be different. And I've heard and I've talked a lot with Jane Ledsby, who works a lot on like this error handling. I think the error handling team. She probably like is the lead of it, I think. And so it's very cool to hear her talk about stuff when I go to these meetups, because I'm getting exposed to these problems that I'm not super familiar with. But I mean, and also when you don't have your own criticisms of a language or something that you're using, then it often suggests that you don't know as much about it as you should. Because I mean, you should always you should be able to be critical of stuff that you use. And so, great question, but I don't think I have a good answer for that.
No, no, trust me, you really have good answers. I don't think I can expect such good answers from anyone else. We have one more. We have one more trivia question for you. So during the workshop, it just happened to catch my eye. There are very few people I know who use that particular distro of Linux. So can
Yeah.
we have some feedback of Garud?
Yeah. And so I in my first few years of university, I used Windows religiously. I'm like, oh, this is the perfect operating system for development. And then I started using like Ubuntu, and I'm like, well, okay, it's kind of cool. Like I can do a lot more from the command line. I can trust that when I'm building something, like Windows isn't gonna interfere with it as much. But then I started working down the road of like, okay, well, what other distros are out there? So I started with Manjaro, and this was like um, an Arch based derivative. And so after that, after Manjaro, using Manjaro for a while, I saw Garuda. I was like, I want to distro hop to something cool. And Garuda is like batteries included. It includes like all of this cool stuff that like helps like your memory do better, and it looks nice, and it's like KDE and it's Arch. And I think there's a lot to like about it. And so, for example, well, a lot of stuff that's sort of more risky as well. Like instead of using the Arch user repository by default, it uses what's called the chaotic R. And so instead of you compiling code yourself when you are installing it from the package manager, you just install a binary that's already been built. And so there's like security implications behind all that. But then the other benefit is that like instead of having to like whenever I type a command into the command line and it doesn't it's not installed, then it will automatically look it up and install it in like 10 seconds, and I can start using it. And so I'm taking a functional programming course right now, and we have to use Haskell. And I typed in Haskell, like whatever, GHI or whatever, and it wasn't installed. And then it was like, do you want to install it? I'm like, yes. And then 10 seconds later, I had it. Whereas on Windows, you'd be like, okay, got to install the executable, got to add it to my path, got to do this and this. And so I think Garuda has a lot of really cool stuff, and it has exposed me to a lot more about Arch than Manjaro did, just like in ways that I'm using it. But at the same time, I've also had a lot of problems with KDE working with my graphics card, and parts of like my hard drive not doing exactly what I want. But this is more of me not knowing how it works or me not setting up my hardware properly. And so it's like, if you want to do the deep dive into Linux, you just have to be prepared to learn a lot more about how stuff actually works.
Hmm. I see. And now that you mentioned that Garuda is a derivative of Arch, I would like to point out. So I am still a Windows user. I still confine myself to Windows and using Linux within virtualization. There's something known as MSys2, which is a really popular way of using GNU-based compilation utilities in Windows. So it's like a complete GNU slash Linux based development environment within Windows. All the MinGW related compilers are readily available using that, and it is actually based on Arch. So I have been using it for quite a long time, and Pac-Man has troubled me a lot. So it has been quite a struggle trying to figure out those commands with Pac-Man. But now I have been using it for quite a long time. And the name Garud Linux. So the word Garud is actually an Indian word, which,
Oh,
yes, that's why I'm pronouncing it that way. So Garud actually means uh, eagle. So it's like Garuda means eagle.
uh-huh.
It refers to that bird, and it is also well known to be the ride of a particular Hindu god. Which is why I think one of the founding team members of Garuda Linux was an Indian person. That's why they ended up with this name. We
Awesome.
have
That's really cool to learn, because like, so for me, I thought it was just a cool name, but it doesn't sound like an Indian word to me, or like at least how I would pronounce it. And so that's super cool to hear. And then also it makes sense because on their website they have an eagle there, and so that does make a lot
yes,
of sense. So that's really cool to hear.
yes. That's why it's called Garuda. Yes. Actually, most people pronounce it like Garuda, but it's Garud like that.
Okay.
Mhm. So we have one last question for you. We talked a lot about WebAssembly today when you mentioned your friend wrote a blog about how Amazon started using WebAssembly for Prime Video, and it really made things easier for them, reducing the build size and making it more efficient.
Hmm.
Uh, WebAssembly is definitely going to rise in the coming future, and Rust is going to as well. But do you think that WebAssembly can fuel the rise of Rust?
Yeah, so I think definitely when it comes to like what the development process looks like in Rust right now for making something in the web, like I really like doing backend stuff. I like dealing with data. I like dealing with like logic. I don't like doing front end stuff so much because like my HTML and CSS skills are not very good. And so when I'm working with a front end developer, so I worked with a friend to work on this, the front end that I showed off. The process was a lot about me dealing with all the Rust side, and then him dealing with all of the um, like the front end code, making stuff styled and everything like that. And so I think in the long run, when it comes to how like WASM is like inevitably going to gain popularity, just because like the way that you can ship code and optimize and run code is very different in JavaScript and gives a lot of benefits. Um, I think it's definitely one area that's going to help with Rust a lot, but then it's also like there's so many different teams that are working on so many awesome things in Rust that it's very difficult to say which one will be like the big part of Rust that takes off. So, for example, if it becomes like a ubiquitous systems language, so like for example, I know a lot of different. I read a post recently on Reddit about how a university in Poland is teaching Rust to their either first or second year students, and so as a like systems
Mhm.
language to learn about a lot of these primitives of memory management and stuff like that, I think that's really great. And so if it becomes ubiquitous as the language that people can use for system stuff, or if it becomes like in game development, it solves a lot of problems that have existed in game development for a long time. Primarily the idea that when we're doing logical code in video games is very difficult to parallelize it, because historically we've used object oriented programming, and this can be a lot more difficult to split up across cores. And so in game development, it has like a lot of area. In web development, as you said, on the front end, WASM is great. On the back end, Rust is real fast. And so, like as far as I know, like one of the Rust web servers, Actix, it's one of the fastest, if not the fastest web server. I could be mistaken about that, but it's definitely up there. And so it solves problems there. Machine learning and ML and all of this. Currently, like when you use PyTorch or TensorFlow and stuff like this, as far as I know, is Python calling to C bindings. And then whenever you're coding stuff in C, like you're definitely
Mhm.
C is very fast, C can do a lot of really great magic. You can make anything you want in C, but Rust makes it a lot safer. Rust makes it a lot easier to potentially solve some problems. And so I think that there's a lot of places that will help Rust gain popularity. And I'm definitely invested in a lot of them myself. And so I love seeing when like we hear blog posts. So it's really great that I'm able to work on projects in Rust and I'm able to do my own stuff. But it's even like really like a lot um, better to see industry taking it over. And so I think this is where we'll see a lot of the lead in the future.
Mm-hmm. I see. I agree with you. And I would like to take this opportunity to talk about Robin, Robyn, which is a Python-based web server that has a very similar API and interface to Flask,
Mm-hmm.
but it's completely so the runtime is completely made in Rust, which is why it's very fast and efficient. And it has been developed by GitHub at the rate Sansi Rocks, Sanskar JT, which is also an Indian campus expert. So we
Oh,
have, yes, we
very cool.
have one more question in the chat. Why is it named Rust? Any story behind it?
Yeah, so I saw that. So off the top of my head, I am not entirely sure. Um,
Mhm.
and I feel like I've listened to some podcast where it talked about this. A little bit of Rust history. Rust started at Mozilla as like an experimental project that was like what, and so it was started by Graydon Hoare, who is a very like as far as I know has done like a lot of work in like language theory and research in this vein. And so Graydon started the project because um, they want to just play around some cool typing ideas or something like that. And then as far as I know, it became like a much larger project once the idea of memory safety and the borrow checker came in, and this idea of like being able to give guarantees that have to be enforced through code. And so I don't exactly know like where in the process like the name would have come up, if it like when it changed from like being like a super secret Mozilla thing to being like open to like a lot more people coming in and working on it. But yeah, that's a really great question. There's probably some like interesting lore like in the background that will that's like a pretty cool reason for it.
I think we have something to look up at after the end of the workshop.
Yeah, exactly.
Mm. So, thank you very much, Forrest. It was really nice to have you. Am I receiving a call? Sorry about that.
No worries.
It was really nice. It was really nice to have you here at our community, Forest. Really enjoyed the workshop. Thank you very much. I'm pretty sure students at our community will be enthusiastic about developing projects in Rust in the coming days, and hopefully, we'll have contributors in Valorant from our community as well.
Awesome.
Thank you
So
very
great to
much.
hear. And thank you so much for the opportunity to speak about Rust. As I mentioned, people who know me know that I love talking about Rust, and so it's awesome. I think to be part of this GitHub campus expert community where I'm able to meet someone from India who is 10 hours ahead of me and come give a talk at their university. So thank you so much for this opportunity. It's been great.
Thank you very much. It was really nice having you at our community, and hopefully, we'll have you at our community again in future. Let's continue collaborating and spreading awareness in the tech world.
Awesome.
Nice to see
Cheers.
you, Forrest. See you
You too.
again.
See
Goodbye.
you later.